हिंद आईएएस एकेडमी के यूट्यूब चैनल पर स्वागत है। दोस्तों, यदि आप हमारे इस चैनल पर नए हैं तो हमारे चैनल को सब्सक्राइब करना ना भूलें, जिससे आप सभी को आपके टॉपिक से रिलेटेड कंटेंट का अपडेट मिलता रहे। देन आफ्टर, अगर आपको ये वीडियो पसंद आता है, लाइक करते हैं, तो आप लाइक का बटन अवश्य प्रेस करें। और यदि आपको कोई सुझाव देना है तो आप हमारे कमेंट बॉक्स में सुझाव दे सकते हैं। और यदि आप कोई अपने डिज़ायर टॉपिक पर वीडियो चाहते हैं तो उस पर भी हम विचार कर सकते हैं। आइए हम आज आपके समक्ष हम और आप मिलकर ऑप्टिक्स के टॉपिक रिफ्रैक्शन को आगे बढ़ाते हैं। जैसा कि आप सभी को ज्ञात है, जिन मित्रों ने हमारा पहले का वीडियो देखा है उनको पता होगा कि हमने रिफ्रैक्शंस पर कई सारे वीडियो अपलोड किए हैं। तो उन्हीं की श्रृंखला में आज हम आप सभी के समक्ष रिफ्रैक्शन ऑफ लाइट के कुछ एप्लीकेशंस बेस्ड वीडियो बनाने जा रहे हैं और उस फिनोमिनन्स को एक्सप्लेन करेंगे जो रिफ्रैक्शन की वजह से होती हैं। जैसे आप सभी जानते हैं कि रिफ्रैक्शन जब होता है तो एक मीडियम से दूसरे मीडियम में लाइट जाती है, तो उनकी वेलोसिटीज़ में डिफरेंस की वजह से वो अपने पाथ से डेविएट हो जाती है। तो हमने आपको बताया रिफ्रैक्शन थ्रू ग्लास स्लैब, हमने बताया लेटरल शिफ्ट क्या होती है, लेटरल शिफ्ट का एक्सप्रेशन क्या होता है वो भी बताया। आज हम आपको बताएंगे अगर कोई भी ऑब्जर्वर रेयर मीडियम में हो तो उसकी रियल और अपेरेंट डेप्थ पर क्या इम्पैक्ट होगा, और यदि ऑब्जर्वर डेंसर मीडियम में हो तो उसके रियल और अपेरेंट डेप्थ पर क्या इम्पैक्ट होगा। तो जनरली हम यहाँ पर अपने टॉपिक को तीन चार पार्ट्स में डिवाइड कर देते हैं। जैसे मान लीजिए हमारा फर्स्ट केस है कि व्हेन द ऑब्जर्वर इज इन द डेंसर मीडियम, एंड सेकेंड व्हेन ऑब्जर्वर इज इन द रेयर मीडियम। और उसके अंदर भी हम इस पॉइंट को कैटेगराइज कर सकते हैं और कैटेगराइजेशन के अकॉर्डिंग हम ये बताएंगे कि अगर ऑब्जर्वर उसको नॉर्मली व्यू करता है, नॉर्मली, जैसे यहाँ पर अगर ये एक कंटेनर हो, दिस इज द कंटेनर, आप मान लीजिए कि ये कंटेनर है, इस कंटेनर में यहाँ पर पानी भरा हुआ है, कोई भी लिक्विड है यहाँ पर, इट्स एनी लिक्विड। देन इफ ऑब्जर्वर व्यू दिस नॉर्मली, मान लीजिए लाइट रे ऐसे आई और ऑब्जर्वर ने इसको नॉर्मली व्यू किया, तो उसकी रियल और अपेरेंट डेप्थ में क्या चेंजेस होंगे। अगर ऑब्जर्वर उसको नॉर्मली व्यू करता है तो रियल और अपेरेंट डेप्थ में क्या चेंजेस होंगे। अगर जो है ऑब्जर्वर नॉर्मली व्यू नहीं करता है और वह जो है ऑब्लिकली व्यू करता है, अगर ऑब्जर्वर जो है व्यू और व्यूड ऑब्लिकली, तो उसकी रियल एंड अपेरेंट डेप्थ पर क्या चेंजेस होंगे। तो हम यहाँ पर अपने पूरे स्टडी मटेरियल को तीन चार पार्ट में डिवाइड करते हैं। पहला केस है हमारा केस 1, ऑब्जर्वर इन रेयर मीडियम व्यू नॉर्मली, व्यू obliquely, and second case, observer in denser medium and same thing, view normally and view obliquely। इस तरीके से आपको यहाँ पर कंसीडर करना है। यू कैन कंसीडर accordingly। Then after you observe this thing, so our basic motto is to explain and calculate real depth with the difference of virtual depth, and there is an impact on the observer's angle. So before going to start on the topic, we must know about these concepts. Clear? Means one more important point here is that you just take a pencil and drop the pencil in the water and you see the bending of pencil. This is due to refraction. Refractions can be categorized in a homogeneous medium and in a non-homogeneous medium. Homogeneous medium is an isotropic medium and non-homogeneous medium is a anisotropic medium. Atmospheric refraction is one of the example of anisotropic or non-homogeneous medium. We are discussing about the real and the apparent depth. So I explained that when observer look normally and when observer looks obliquely, in a both due to the difference of the angle we get a different expression. So let's see our first expression regarding the virtual and real depth when observer see or look normally. So case 1 is that when observer is in rarer medium expression for real and apparent depth. Let assume there is a beaker or any vessel. This is the vessel. Here a coin is placed at point O. Then this is the interface boundary. And then light emerges from point O, it get refracted due to different density of the medium, and one light is go normally. One light is go normally like this way, and here, and this is the angle of incident, angle of refraction, and this is appears to come from this point. It appears to come from this point O A B. Now this R, and if we consider vertically opposite angle, this will be equivalent to R, and M N and C R C O is a parallel line, so this is I. This will be I. Let assume this is the fill with water. Let assume this is filled with water, and this is the point I. Clear? And so you just know this is the H, and from this become H dash. Here few important parameters. H dash is the consider at apparent depth. We consider H dash is the apparent depth, H is the real depth. Clear? And refractive index of the rarer medium is mu1, and refractive index of denser medium is mu2. Here we said refractive indices, refractive indices are mu1 and mu2 respectively for rarer and denser medium. Clear? Refractive index. And here the condition is applicable, and here the condition is applicable. What condition is applicable? Light is passes from denser to rarer medium, and you know that when light passes from denser to rarer medium, angle of refraction will be greater than angle of incidence. So here R greater than I, and for what? Light is passed from denser to rarer medium, and observer is situated in rarer medium. Object is situated in the rarer medium. ये ऑब्जर्वर हो गया. तो अब यहाँ पे हम अगर ऑब्जर्व करें तो हमारे पास दो ट्राइंगल्स बन रहे हैं. दो ट्राइंगल्स AOB and AIB. There are two triangles, and you also assume this is I by sorry, this is the R by concept of parallel line. So in triangle AOB, by the concept of trigonometry and concept of parallel line, we have angle I, and for triangle AIB we have angle R. Refraction angle. So I is the incidence angle, R is the angle of refraction. Then using the concept of trigonometry, in triangle AOB we have sin I is equal to O perpendicular AB upon OB. Then again in triangle AIB we have sin R is equal to AB upon IB. This is the second. Then clear, sin R is equal to AB upon IB. Triangle AIB, AIB, this and AOB. Now dividing both using Snell's law, sin R is equal to AB upon OB upon IB. Then sin I upon sin R, AB by OB into IB by AB. Just divide, we get sin I upon sin R is equal to IB by OB. This is our third equation. The general formula. Here I got the general formula when observer is in the rarer medium, real and apparent depth. We wish to calculate. See, sin I by sin R is equal to IB upon OB. IB this and OB that. Here we observing that this is the hypotenuse, not the vertical line, but here we categorize this condition in two terms. Term one is that when observer looks normally. Second, when observer looks obliquely. So first we frame our first condition of case 1 is that when observer case 1 when ऑब्जर्वर लुक नॉर्मली, जब ऑब्जर्वर इसको नॉर्मली देखता है तो देखिए फॉर दैट sin I will be equivalent to I and sin R is equivalent to R, because when observer looks normally, sin I and sin R become so small, and this can be equate as sin I equivalent to I and sin R equivalent to R. So OB is equivalent to AO and IB is equivalent to IA, means OB जो था वो आपका OA हो जाएगा और जो आपका IB था वो आपका AI हो जाएगा। तो अगर हम यहाँ पर देखें तो OB equivalent to AO is equal to H, real depth, and IB is equivalent to AI is equal to H dash, apparent depth. Now, according to formula, sin I upon sin R is equal to IA upon OA। क्लियर, ये हो जाएगा और यहाँ पर ये हो गया 4, और जब यहाँ पर रखेंगे व्हेन आई कीप द वैल्यू साइन I अपॉन साइन R इज इक्वल टू H डैश बाई H फिफ्थ, दिस इज आवर formula. And one of the very important point is here that what Snell's law said, sin I by sin R is equal to mu 2 by mu 1 is equal to 1 mu 2. Snell's law, this is a Snell's law. Here light is passing from denser to rarer medium, so 2 mu n, because light is passing from medium 2 to 1, 2 mu 1 is equal to H dash by H. This has become 6, since by the principle of reversibility of light 1 mu 2 into 2 mu 1 is equal to 1. So 2 mu 1 is equal to 1 by 1 mu 2. 2 mu 1 is equal to 1 by 1 mu 2. Replace this value in 6. You get 1 by 1 mu 2 is equal to H dash by H. Then implies 1 mu 2 is equal to H by H dash. हमको we get here a expression regarding virtual depth or apparent depth and real depth when observer is in the rarer medium and looks normally. So refractive index 1 mu 2 is equal to real depth upon virtual depth. This is the formula which I get here. It's a very important formula for the calculation of real depth and virtual depth when observer see or looks normally. Now, one is very important thing is here that dear students and competitive aspirants, if you are liking this video, please press the button of subscriber. Subscribe our channel and share this video to other your friends circle, your classmates. And if you liking this video, if you are liking, then press the button of like and be the subscriber of Adhyayan Institute for getting more updates regarding all the sphere of dimensions of knowledge as current affairs, sociology, psychology, history, geography, economics, Indian economy, science, mathematics, all other very important subjects of humanities, science, and other technical subjects, and few are from commerce side also. Then one is a very important thing here, vertical shift. We are just knowing about vertical shift. This is the last point of this expression when observer look normally. Vertical shift. Vertical shift. Vertical shift is a very important point. What is the vertical shift? If you observe, then see from O to A to O, this is the real depth, and from A to I, this is small h dash, this is virtual depth. Then difference of both represented by small d. This is known as a vertical shift, means difference of, means you can write difference of real depth and virtual depth. Difference of real depth and virtual depth is known as or called as vertical shift. Vertical shift is small d. So, vertical shift according to diagram, vertical shift is d real depth minus virtual depth. This, so d is equal to h minus h dash. Generally we can get, but we can express more. This is the ninth equation. You know that 1 mu 2 is equal to h by h dash. This is the 10th. Here you can write the value of h dash implies h dash equal to h by 1 mu 2. This replace in this ninth equation, we get d is equal to h minus h by 1 mu 2. Then d is common, h 1 minus 1 by 1 mu 2. This is the expression for virtual. This is the expression for vertical shift. D is equal to h inside bracket 1 minus 1 by 1 mu 2. This is the vertical shift. And you know that we have discussed earlier that 1 mu 2 into 2 mu 1 is equal to 1. Then here you can also write what you get. 1 2 mu 1 1 by 1 mu 2. So your formula become D is equal to h 1 minus 2 mu 1. Is also your formula. 12th. So here we summarize the topic. So we can summarize the topic on 3 basic important formula of case 1 of this topic. What? Let's see. And our procedures here look normally. So we can summarize. Our summary is sin I upon sin R is equal to h dash by h. This is the first. And 1 mu 2 is equal to h by h dash. Second, vertical shift D inside bracket 1 minus 1 by mu 2, and D is equal to h 1 minus 2 mu 1. All are here, and you can get your answer by using one of them. And here you can write your symbol h dash virtual oblique apparent depth, h real depth, D vertical shift, and mu refractive index. Sin I and sin R, you know that angle of incidence and refraction. So dear aspirants and our viewers, how was that video? And I wish that I try to represent best. And if you have any suggestion regarding this content, you can comment in my comment box. And finally, I thanks to our viewers, our subscribers, our new viewers, our unique viewers, and all the viewers who are watching my this lecture. I thanks to all and suggest and request to all, please subscribe, like and share this video to spread the knowledge of to all our domains. So thanks for watching, and finally I say to you, thanks for your keeping full patience to watch me. to follow me. Thanks for watching once again.